This is a really hopefully quick and brief follow-up video to the last one we did, in which we discussed the elementary row operations, but we had mentioned row echelon form. Okay, and so let's go ahead and bring that up right now. You'll notice this is the same system I just used in the last video, and this is the corresponding matrix that shows it in row echelon form. So after we had performed all the indicated operations, row echelon form, recall, is the main diagonal here. Okay, with leading ones all the way down it. We say leading ones because these are zeros before and below them, and we typically just ignore them. But yeah, row echelon form would look like this, and in any all zero rows would be at the bottom. Of course, we didn't have any of those. But in this video, we're going to talk about reduced row echelon form. So reduced row echelon form. And I kind of briefly mentioned this in the last video, but reduced row echelon form not only seeks to get ones down the main diagonal and zeros below them in this fashion, but also zeros above them. So if we could get a 0 here, 0 here, and a 0 here, I just wanted to show what that would look like, okay, and also the convenience and the significance of it, okay. So let's go ahead and get started. We're going to start here in our second row, and the reason why is because of our second column. In our first column here, you notice we already have a leading 1 on the top left and zeros below it, okay. We have a leading 1 in our second row. It's just that we have a 0 below it and a non-zero value above it. So we need to make this 2 into a 0. So we kind of work over by columns. So to make that 0, here's what we'll do. We'll add 2 of row 2 onto row 1. Okay, so let's go ahead and, oops, wrong button, write our new row equivalent matrix. Now keep in mind we did operate on row 1, so row 2 and row 3 have not been changed. So we have 0, 0, 1, 2 down here. Okay, and so 2 of row 2 onto row 1. You notice 2 zeros onto 1 still leaves us as a 1. 2 ones onto 2 gives us a 0 here where we wanted it. And then we say 2 threes onto 3, it'd be 3 threes, it'd be 9. And 2 fives onto 9, that'd be 19. Okay, and so now that we have that, let's go ahead and go over to our third column here. We want to start taking this 1 and scaling it and adding it to get rid of this 3 and this 9. Okay, so let's go ahead and maybe eliminate the 3 in row 2. So what we'll do is this. We'll say negative 3 of the third row, and we'll add that on to the second row. And so this is going to yield a new row equivalent matrix where we still have 0, 1, 9, or 1, 0, 9, 19. Down here we still have 0, 0, 1, 2. And now let's talk about our second row. Negative 3 times 0 down here added on to this value here is not going to change it. So we get a 0 here. This still maintains itself as a 1. It's really only these two values now that we concern ourselves with. And we know we just made this 0. But negative 3 of these, this 2 we had down here onto this 5 right here would give us that value of negative 1. So the last thing we need to get down is this guy. So we'll say, okay, so negative 3, sorry, let's go negative 9 of row 3 of those 1s down at the bottom there. We'll add that on to row 1. And so writing this new fresh matrix, row equivalent, whoops, we're operating on row 1. I'll just leave that alone for now. 0, 1, 0, 0, 0, 1, and then this is negative 1 and 2, and here comes the lovely part. Okay, so this still maintains itself as a 0. We just got this to go to 0, and if we were to take negative 9 of these 2's, it'd be negative 18 onto our 19, okay, we'd get 1. And so now rewriting the corresponding system that corresponds to this matrix, we'd say we have 1x plus 0y plus 0z is just simply 1. We have in the second row just a y, 1y, and that's equal to negative 1. In the third row we had just 1z, and that was equal to 2. Okay, and so the beauty of this reduced row echelon form is, yeah, you have to include a few more steps, but other than that, it really just gives you the solutions here on the right, which is what we want. Okay, so let's take a look at maybe a couple of other cases here. We'll try to do these again, and I'll be upfront with you here. We got x minus y. I've got a couple of systems that I wanted to look at really quickly, but these are unique systems in that I've got the first one here is going to end up with no solution. I just want people to see what does it look like when you have a matrix that ends with no solution. And so here's what we got. 2x minus 3y's. What do I got? Plus 5z's, and that's 4 constants. And then last but not least, 3x plus 2y minus z, so 3x plus 2y minus z is, I've got 1. Okay, so let's write our augmented matrix here, first of all. So this matrix here, we'll go column-wise. 1, 1, 2, 3. We got -1, no y's here, -3 of them here, and 2 here, 2 z's, 1 z, 5 z's, and -1z. We'll augment this. So we got 4, 6, 4, 1. So 4, 6, 4, 1. Okay, so let's go ahead and get this party started. How about the fact that we've already got a leading 1 here, which is awesome. We want to start getting things below it to cancel out and come to 0. So let's do a few things here. Nothing wrong with combining 2 steps at once, and the better you get at this, the more you'll do it. But let's add negative row 1 to row 2, which will get this guy to cancel out. Let's add -2 of row 1 to row 3, okay, and then -3 of row 1 to row 4. So lots of things going on. We got 1, -1, 2, 4. First row doesn't change. These should now be zeros. Okay, we got those to go to 0. It's just what's left in the rest of the row. Let's go ahead and take a look. Negative row 1 to row 2. So negative row 1 on this -1 up here, make it a +1 on top of the 0. Make this a 1. -2 added to 1, -1. And then -4 added on to 6 would give us a 2 here. Third row, we added -2 of row 1 onto the third row. So -2 of these -1s here. So +2 onto that -3 is -1. Okay. -2 of this 2 up here, -4 onto our 5 is 1, positive. And then -8 onto our +4 is -4. And then the last row here, -3 of row 1 onto the last row. So -3 of this -1 is +3 onto our 2 is 5. Okay. Let's see, -3 of our 2 here is -6. -6, that's kind of confusing right there, that's a 2. -6 on to -1 is -7, and then -3 of 4 is -12 on to 1 is -11. Okay, so moving right along, we've got a leading 1 here in our first row, leading 1 in our second row. Okay, we've not got a leading 1 here. Okay, but we can try to get this. We can take this leading 1, and we've got to make everything below it 0. Okay, we're gonna make everything below it 0. Let's go ahead and do some row operations. We got, okay, so we will take this and add it to our third row. We've got row 2 plus row 3. So 1, 0, 0, 0, -1, 2, 4. We didn't change row 2, so it's still 1, -1, 2, and the last row is still pretty static. 11. So now this is a 0. That's what we wanted. We're going to add row 2 to row 3. So -1 plus this +1 here, we get a 0 here as well. And then 2 plus -4 is -2. So now it's at this point I just kind of want to stop and say, all right, well, hey, check this out. This is an almost all 0 row. If it was an all 0 row, we'd throw it to the bottom, row echelon form. But what you're seeing is this. If we were to rewrite the corresponding system, you actually generate an equation that is making this statement, which is an invalid statement, okay? And so, you know, when we've seen systems like this in the past in which we get all our variables to cancel out, and you get an invalid statement, we say those are no solutions, okay? So this is an example of a system that has no solutions, okay? As far as infinitely many solutions go, I'm going to end the video here. There's not a lot of room to write, but you'll probably be able to find one on the web.